Alright, this is video number 3 of 5.2, where we're talking about the properties of rational exponents and radicals. This will help you with the 5.2 practice on big ideas. So in this video, we are writing radicals in simplest form. So we're just going to hop right to it. Writing that radical in simplest form. So I need to simplify this radical. So there's a couple ways to do this. So I'll show you multiple ways. Now this is a third root. So if I find a perfect cube root that can go into 135, and if you remember, those perfect roots were like, if I take 2 and I cube it, I get 8. 3 and I cube it, I get 27. So these are those perfect roots, okay? And you can keep going. 4 cubed, 64, okay? All of those. If any of them go into this, then that's a perfect cube root, right? So 27 goes into this, so I can actually just stop right there. So I have the cube root of 27 times the cube root, and if I divide 135 by 27, I get 5. Okay? I can take a cube root of 27 and I get 3, but I can't cube root 5, so I'm going to be left with 3 square root of 5. Okay, so if you have trouble with those perfect cube roots, another way to do this is if I take 135 and I take out the smallest prime number, okay? It's not even, so 2 doesn't go into it, but 3 goes into it. So if I divide that by 3, I get, actually let's divide by 5 to start with, because it ends in 5, so that's the easiest one to take out. Let's start with 5. Just a prime number that goes into it, okay? So I get, let's see, 27. Oh, well, yeah, I guess I showed that right there, didn't I? Okay, and then 3 goes into 27 9 times. 3 goes into 9 3 times. Now I'm left with all prime numbers. Now because this was a cube root, I want a group of 3. Here's 3 3s. That's what comes to the outside of my root. I only have the 1 5, so it has to stay inside my root. And then my root just needs to make sure it has that 3. Okay, so you can get the same answer doing either perfect cubes or doing this little factor tree that I did. Okay? Alright. So number 13. Okay, these are both to the 5th root. But even if I combined them, I can't take 7 divided by 8 and get a nice pretty number. So what we need to do here is make it part of our rules for simplifying. When we had things in simplest form here, we talked about this. Okay, we cannot have a radical in the denominator. Okay, so this 5 square root of 8 has to go away. So I want to think of something that I can take a 5th root of and get a nice pretty number. And the easiest number is 2 to the 5th is 32. So 32, the 5th root of 32 is 2. And I can multiply 8 by something to get to 32. Okay? And in that case, I have to keep the 5th root. Okay? But I want this to be a 5th root of 32 when I multiply them together. So it's 8 times 4 is 32. But if I multiply the denominator, I have to multiply the numerator. So on the top, I have the 5th root, and we multiply the 7 and 4. In the denominator, I have a 5th root of 32 when I multiply the 8 and the 4. Okay, so the top does not simplify. You can always try it out, make sure, but it doesn't. Okay, 5th root of 32 is 2. So now I no longer, we have to have, oops, let me make it so you can read the rules here. No radicands have perfect nth powers as factors, other than 1. And no radicands contain fractions. So my answer doesn't contain fractions. And no radical appears in the denominator. Okay, so we followed all the rules here. All right, number 14. Excuse me. All right, so this is where we need to do, let me throw in some of that vocabulary on the front page before we get to 14. We've talked about conjugates last semester. Okay, it's where we change the sign in between the term. Okay, so I need to multiply the denominator by the conjugate of 5 plus square root of 3. It'd be a 5 minus square root of 3. But if I multiply the denominator, I have to multiply the numerator. So that leaves me with the numerator of 5 minus square root of 3, because 1 times all of that. Okay, you take 1 times 5, and 1 times negative, or square root of negative square root of 3. Okay, and when I multiply the bottoms, the conjugate is the one and only one where you can just multiply these. You get 25. And square root of 3 times square root of 3, you got the minus, because a positive times a negative is a negative. Square root of 3 times square root of 3 is 3. Okay? You could do the whole box method, because really what you do is distribute, but you get a 5 square root of 3 and a minus 5 square root of 3, and they cancel out. So this is the one time when you deal with conjugates that you can actually just multiply the first terms times the second terms. Okay? So if I simplify this, the top is still 5 minus square root of 3. And the denominator is now 22. And that does not simplify anymore. Okay, so it's not ending this video, but now you can pause the video and go on to 22, 23, 26, and 28 in the practice. That goes with those problems, and then we'll resume with number 15. All right, so we want to simplify this. Well, 4, I'm going to separate everything out, kind of think of it a little differently here. I can't take a 5th root of 4. That's just not going to change. So I'm going to leave my 5th root here. I'm going to have the 4. But a 5 does go into 8. So I'm actually just going to write a to the 5th. And then I still have 3 more a's, right? Okay, because remember we add the powers to come, so I'm kind of going backwards from simplifying the radical, or the powers here. So 5 plus 3 is the 8. So I separated it out into 2 because I want powers that 5 go into, okay? It doesn't go into the 3, but it does go into that 5. All right, then b to the 14. Well, I want the highest number of 14 that 5 goes into, and that is 10. But I still have 4 more b's. And then c to the 5th, 5 goes into that, so I can just leave that like that. So to simplify this, anything that had a power that I can divide by 5 is going to come out. Okay? Remember, this is the same thing as saying the power is 5 over the root. So it's power over root. So 5 divided by 5 is just 1. So I have the a on the outside. So I took care of that one. So I'm going to kind of cross it out so I don't get confused. Then power here is 10. The root is 5. So 10 divided by 5 is 2. So I have b squared. And I took care of that one. And then I have c. 5 divided by 5 is 1. So I just have the c. And I took care of that one. Now, the root of 5 doesn't go into anything else that's left. So I have to have the 5th root. I have a 4. I have a cubed. And I have b to the 4th. And that's as simplified as that gets. And again, this is one of them that you could have really done a lot of writing here. We say we have a 4. Then we had 8 a's. Then we had 14 b's. Okay, I'm not going to write them all out, but lots of b's and 5 c's. Okay, and for every group of 5, 1, 2, 3, 4, 5, that a goes to the outside. Then I have 3 a's left. Okay, and that's what we ended up doing when we just did it this way. Okay, so you can write them all out if that helps, or just take out the whatever the root is, that many ones that are powers that are divisible by that. All right, so number 16. All right, I have a radical in the denominator. Excuse me. Sorry about that. So I have to get rid of that radical in the denominator. So I can take a cube root of 6 of these, but it doesn't go into 8. So I want to multiply. I can take a cube root of y to the 9th. So I need one more y in the denominator. So since I put it in the denominator, I also have to put it in the numerator. So that leaves me with an x times the cube root of y over the cube root of y to the 9th. Okay? Because we add the powers. Remember, if it doesn't have a power written, it's power 1. So 8 plus 1 is 9. Okay? The numerator is going to stay the same. Cube root of y over, and my power is 9, my root is 3, so 9 divided by 3 is y cubed. Okay, and that is as simplified as it gets. Follows all those rules. Okay, number 17. Alright, so we want to simplify this as much as we can. Well, I can simplify the numbers to start with. So I'm just going to write my fraction here, okay? We may or may not need it, but that way I can simplify things. The bigger number's on the top, so 14 divided by 2 is 7, so the 7 has to go on the top. Okay? Then I have an x in the numerator and denominator, so we have to subtract. We take the numerator's power, which is 1, and subtract the denominator's power. Then I have a y in the numerator. I do not have a y in the denominator, so I'm just going to write y to the 1/3. Just has to stay there. And so I've taken care of the 14 and the 2. I've taken care of the x and the x to the 3/4. I've taken care of the y to the 1/3. And now I'm left with the z to the -6. Now remember that negative rule moves the power, or the variable, from the bottom to the top. If it's in the denominator, it needs to move to the numerator. If it's in the numerator, it moves down. So to get rid of the negative, we're going to move z to the 6th to the top, and now the negative's gone. Okay, so right now it looks like we don't have anything in the denominator. Let's make sure that stays that way. I'm pretty sure it does just by looking at it. So I'm going to have a 7. I'm going to have an x, and I have 1 minus 3/4 is 1/4. I have y to the 1/3, and I have z to the 6th. There was nothing left in the denominator, so that is as simplified as this gets. Alright, so now go to the practice and do number 58, 59, and 64, and then move on to the fourth and final video.